Howdy folks, welcome back to this last video which will wrap up section 4.4 and looking at trigonometric functions of any angle. So let's read on. So utilizing a unit circle approach, we can analyze angles of any measure. However, by relating angles greater than 90 degrees to a corresponding acute angle, we can use its reference angle. So the whole point of this is really because we know all of our trig functions are positive in the first quadrant. If we can somehow map it back to that first quadrant, we can get those values maybe pretty easily, and then we just have to remember the positives and negatives when we're in different quadrants. So let's see what that's all about. So reference angles. So if theta is a non-quadrantal angle in standard position, so non-quadrantal means not 90 or 180 or 270. In standard position, then the reference angle for theta is the positive acute angle theta prime, formed by the terminal side of theta and the positive or negative x-axis. So very important that we don't try to use the y-axis in developing these reference angles, just the x-axis. So let's look at the first case. So if we're in quadrant 2, so this is quadrant 2, not this one, but over here. So we have an angle that has its terminal side in quadrant 2, so we can see our angle theta is there. So they're saying that this reference angle is this little acute angle here between the terminal side and the negative x-axis here. So now the million-dollar question is, what is that angle equal to? How could we find that based on the information we're given and just knowledge of our overall angles for this problem? So if we wanted to say that theta prime is equal to something, so what can you recognize if we looked at both of these angles together? Theta prime and theta together, you can see does equal 180 degrees. So if we take the overall 180 degrees and subtract theta from that, that's going to leave us this little tiny angle. So that's the formula for this reference angle. So 180 minus theta will give us theta prime. Now obviously we can change that into radians if we want. So instead of 180 degrees, we can say pi, same difference. So let's look at quadrant 3 now. Quadrant 3 case, you can see we have our theta that goes all the way down to the third quadrant. And so now they're saying theta prime is this acute angle, again, between the terminal side and the negative x-axis in this case. So how could we find theta prime? Well, we still can use this 180 degrees to our advantage, but it's going to look a little different than our previous case, because now theta is bigger than 180 degrees, so we want that first. So this is going to end up being theta minus 180 degrees, and that will give us this acute angle theta prime. All right. And so our last case, which is quadrant 4, so again, we got our whole big theta angle that stops into the fourth quadrant. And so now they're saying that theta prime is this little acute angle. So what do we notice about this diagram? Well, you can see we have a whole circle here when we have everything combined. So the trick to this one is going to be to use 360. And if we subtract theta from that, that will give us this theta prime, this little angle here. So now we have this reference angle that we can find. So hopefully we can use that to our advantage when we're finding our trigonometric functions. So let's try a few problems. So these first one is just asking you to find the reference angle theta prime, and they want you to do just a quick sketch of the angle in standard position, and then of course label theta prime. So if we have an angle of 160 degrees, then, well, what quadrant is that in? So that's the first question. So hopefully we can recognize that this should be in quadrant 2. So if this is in quadrant 2, we can do our sketch pretty quick. And we're going to end somewhere in quadrant 2. So there's our 160 degrees. So now if we want theta prime, what did we say just a minute ago? Well, that should be this little angle here, and we can quickly see that that must be 20 degrees. But we could use our formula just to be safe. So we know we'd have to subtract our angle from 180 degrees, and we do get 20 degrees for our theta prime. So really pretty quick. All right, so let's try one that's in radians. So if we have 4 pi over 3 for our angle, well, again, what quadrant should that one be in? Well, now you can transform this into degrees if you want to make it easier to visualize, but remember, pi is 180. So how does this compare to pi? Is it bigger? Is it smaller? And you should be able to determine that that 4 pi over 3 is bigger than pi. So that immediately pushes it into the third quadrant and maybe the fourth, depending on how big it is. But now you have to ask yourself, is it bigger than 3 pi over 2? So 3 pi over 2 is 270 degrees, so that would be straight down. And if we do a little bit of checking, we can verify this doesn't go into the fourth quadrant. This would be a quadrant 3 scenario. All right, so now if we want to draw our sketch, we need to draw into the third quadrant. So I'm thinking it's going to look something like that. So there's our 4 pi over 3. And so now what is our theta prime going to be? So remember, theta prime always goes back to the x-axis. It might be the positive or the negative, but in this case, it's closest to the negative x-axis. So here's our theta prime. So what would that be? Well, let's use our formula. So in this case, we want theta minus 180 degrees. Well, since we're in radians, let's just use pi. And so we can quickly do a little fraction exchange, for lack of better wording. And we do get pi over 3. So pi over 3 is an acute angle, and so that should be our reference angle. So not too bad. As long as you use the right formula, it's pretty quick. All right, now let's try to apply that a little bit. So if we have to evaluate the sine, cosine, and tangent of the angle without using a calculator, and we have 2 pi over 3, well, let's first start with our reference angle again. Because once we know what quadrant we're in, then we know what the positives and negatives need to be for those different trig values. So, well, what quadrant are we in? Well, if you do a little bit of thinking, you should be able to determine that this is quadrant 2. So quadrant 2, so our theta prime should be pi minus 2 pi over 3. So again, 3 pi over 3 minus 2 pi over 3, and lo and behold, we have a reference angle of pi over 3. So now this should be an angle that you're familiar with. Now, if you don't recall, this is 60 degrees. Now, if you remember back from 4.2, we looked at how we had a little pattern that we established for finding sines and cosines. So that's really the starting point for this, because if we know the sines and cosines, then we can figure out the tangent pretty quickly. So, do you remember the pattern? Maybe you do, maybe you don't. So, I'll just write some of the pattern out. So sine of 0, remember, was the square root of 0 over 2. Sine of 30 was equal to square root of 1 over 2, and so on. Sine of 45, square root of 2 over 2. Sine of 60, square root of 3 over 2, and then sine of 90, well, I'm running out of space, but square root of 4 over 4. And then it was just the reverse of that for cosine. So again, all we care about is the 60 degrees. So we have the sine of 60, or let's use the reference angle as is. So pi over 3 is equal to the square root of 3 over 2 cosine of pi over 3 is equal to, so remember, it's just the reverse. So we can kind of see that these ones are going to be swapped. So this should be 1/2. And so now the tangent of pi over 3. So what's that going to be? Remember, tangent, we can use the quotient identity. So that's going to be the sine over the cosine. So if we take square root of 3 over 2 over 1/2, well, the 2's are going to cancel out, so this is just going to be the square root of 3 over 1, which is the square root of 3. But that's for our reference angle, so that's not our answer yet. So if we want our final answer, what's the sine of 2 pi over 3? So now we have to think about that second quadrant. So if we're in the second quadrant, the sine is dealing with the y values, and the y values are still positive. So this is going to be the same. Square root of 3 over 2, cosine of 2 pi over 3. Cosine deals with the x's, and the x's are negative in the second quadrant. So we need to negate this 1/2. And then tangent. Well, if it's sine over cosine and one of them's positive and one of them's negative, that forces tangent to be negative as well. So tangent of 2 pi over 3 should be negative square root of 3. And there's your answer. So again, memorizing this is nice, but if you can't memorize it, remember you can fall back to the unit circle where it has it all delineated out. You have those ordered pairs along the outside of it, and that'll help you get those sines and cosines pretty quickly. So if your memory's not that good. All right, let's try this last one, and that'll wrap up this section. So we got find two solutions of each equation. Give your answers in degrees, so anywhere between 0 and 360, and in radians. So do not use a calculator. So remember, we have to kind of use our memory or use those unit circles. So remember, if the sine of an angle is 1/2, so we're going to have, we can use our little cheat sheet up here. I just screwed it away. So if we got 1/2, we know that the angle should be 30 degrees. So that will give us that first quadrant that is true. So we should know that theta is going to be equal to 30 degrees, but where else is it going to be a positive 1/2? Sine deals with the y values. Y values are positive in the first quadrant and the second quadrant. So what would be the corresponding angle? So probably a good thing to do would be to try to visualize a picture. So if we have 30 degrees on one side, well, let me draw it down here. If we have 30 degrees on one side, then the angle that is going to have the same y value is going to have to be the one that makes the 30-degree angle over here. So now the question is what's this angle? And now we can kind of see that that has to be 150. So 150 degrees. And now the last step for this is just to change it into radians. So again, we have those conversion factors that we can use to transform these. And if you can't remember those, remember, if you want to take 30 degrees and put it over 1, you can multiply it by pi over 180, and that will allow you to change it. So you can do a little cross canceling in here. So this would be pi over 6. And then if you did the same thing with 150 here, that's going to cross cancel as well. 30 is going to go into both of those, and that'll give you a 5 pi over 6. So there's that one. Now, if we have the sine of an angle is equal to negative square root of 3 over 2, all right, so again, we're talking about those y values. Y values are negative in quadrants 3 and 4. So they're going to be down below the x-axis. But remember, we can still use our acute angles to kind of give us a little bit of guidance. So we know that the sine of 60 is square root of 3 over 2, and we got negative square root of 3 over 2. So let's get a picture, and then maybe that'll help us. So 60 degrees, so we're going to probably have something that looks like this and like this. So again, this is going to be 60 degrees. This is going to be 60 degrees. So we have to figure out what are these two angles. What's this angle? And what's this angle? Well, to get the first one that's in the third quadrant, we have 180 degrees just to get to the other side, and then another 60 degrees on top of that. So that looks like it's going to have to be 240 degrees, 180 plus the 60. And then for this one, we can kind of go the other direction. If we want a complete circle, that's 360, but we want to lose 60 degrees. So that's going to have to be 300. And now we just have to change those into radians. So same formula as before. So we can put 240 degrees over 1 times pi over 180. And so 60 goes into both of those. So it looks like 4 pi over 3, which we've seen already, previous problems. And then what about this last one, 300? So 60 does go into both of those. And I think that's just going to be a 5 pi over 3. So a lot of, just overlapping of ideas and whatnot. The biggest thing is understanding that first quadrant. That first quadrant is really the key to getting all those other quadrants. They really become easy once you know what the positives and negatives look like in each of those quadrants. So hopefully that was helpful to you, but let me know. And we will see you in the next video, and we're going to be starting 4.5. So stay tuned for that. Take care.